Hey guys, it's Savkant Singh here. Hope you all are doing well. In today's tutorial, we're going to talk on the topic object detection, and we're going to look into its algorithm and how it works. So, a couple of days ago, I uploaded a YouTube short on object detection. By the way, it got a lot of views and also a lot of likes. So, I thought of creating this tutorial on object detection using deep learning. I searched about this topic on YouTube but didn't got a lot of good explanations, or the explanations were code based and they were all complicated. So I thought, why not to create one, a simple explanation with less complicated code or more like good explanation. Now, before starting the video, I would, as always, uh, say to hit the like button and also do subscribe to the channel if you haven't, because it helps me a lot, and turn on the notification bell to get this type of contents. And if you have any queries, you can just comment below, and I will surely answer you. So now we talk too much, so let's get into work. So we are on our Mac, and let me give you a basic like I'll open Safari, and I'll give you very basic knowledge of these neural networks and everything, how it works and all. And I've also created a keynote presentation. I will also show you that. First, I may clear the very basic concepts. Like, the things we are going to use are, like, I'm going to object detection algorithm, and what algorithms are used. No, not this one. Yeah, here we have this algorithm list, and we are using fast RCNN, then this SSD single shot detector. So we are using this both, and we are using a weight file that is frozen interface, like that. Yeah, so this is the convolutional neural network, and this single shot SSD is uh, used with RCNN, so it makes a different kind of neural networks that is faster, because RCNN is fast, like fast RCNN is fast, and faster RCNN is more faster than CNN. CNN is slow, it takes a lot of time. So in object detection, we cannot like wait for a long, like drawing a rectangle, recognizing it. So for that, we are using this convolutional neural network. So, and this SSD, I'm going to clear all the doubts in the keynote presentation. So now let's go here. I want to see what I want to see, like that is, yeah, RCNN. Okay, now it should work. Images, this is the image of RCNN, how it works. Like here we have the CNN layer begins from here, and the input, extract region, proposals, this is working over here. Then wrapped region, it is giving a wrapped region. Then at the end, we are classifying as airplane, person, or TV monitor. So it will give yes, no, like 0110, or array or list, like that. So SSD, it's, yeah, new. We'll show this SSD network. Yeah, it is a SSD network. So here we go. SSD has two components, a backbone model, and blah blah blah, all the definitions. So I'll quit it, and we'll go to the, what's it, a keynote. Here I will just play it and I'll explain you everything. Now let's go. I'll just play it. Yeah. So object detection using basic algorithms. Skip. RCNN. What is RCNN? This is RCNN. I showed you that input image, then extract region proposal, and then at the end it is giving a wrapped region. Then we are uh, executing a CNN, a layer, a compute CNN features. Then because RCNN is something different, regions with CNN features. That means, yeah. So CNN is involved, but it is a bit faster. And then at the end it is classifying as airplane, person, or a TV monitor. So let's skip it. Oh, so what is a SSD? Like single shot detector. SSD has two components, a backbone model and a SSD head. Backbone model usually is a pre-trained image classification network as a feature extractor. This is typically a network like a ResNet trained on ImageNet, from which the final fully connected classification layer has been removed. We are thus left with a deep neural network that is able to extract semantic meaning from the input image while preserving the spectacle structure of the image, albeit at a lower resolution. For ResNet 34, these are outer syllabus. This SD head is just one of the more convolutional layer added to this backbone, and the output are interpreted and the bounding boxes are classes of object in this spatial location of the final layer's activation. Yeah, so it has a backbone and a SSD head. Like backbone means, I guess you all know, you have a backbone, and like in a simple language it is backbone, and a head is the, so it is a pre-trained image classification network as a feature extract. And also, yeah, I just forgot to mention that we are also using a list of names, like it is named Cocos their dot names, that contains all the names like person, bicycle, all the classification names that will be labeling names like that. Uh, yeah, skip it. CNN and SSD detector, like RCNN and SSD are both combined, and what it forms is a neural network, and that is, it looks something like this. Architecture of a convolutional neural network with a SSD detector. First we are having an image, then a pulling one layer, then convolutional two dimensional layer, then three-dimensional layer, then four-dimensional layer, fifth dimensional layer. Then SSD layers begins at the blue layers are SSD layers, single shot detector layers, which are then predicting it as original prediction layer. SSD works on an algorithm to predict layer. So this is how this is a structure of CNN and SSD detector combined. Let's skip. So what are the banes and boons we get in this type of uh, project or this type of algorithm? So the banes are, it is like faster, requires less space, so you can fit it in Arduino also, Raspberry Pi also, you can use them. Like it takes nearly like 10 to 20 MBs of file, or less than that. I need to check that. It takes less than 10 or 20 KBs, and also it is faster. But the boons are, it is like it overlaps a lot. Sometimes the accuracy is very less, so it is not like the accuracy is 100%, 99%, 98%. Sometimes the accuracy is 10%, 5%, or at least 0. It sometimes says that a person is a teddy bear, a teddy bear is a person, like, yeah. So we can use YOLO in that. and we can solve that problem, but it requires a higher space, and this SSD model requires a lower space. So these are the beans and moons we get. Let's skip. So our keynote is completed. Let's quit it. Now I will just run the thing and I will just show you. So plus wait, clear it. Python 3 main.py. I coded it in Python, so here we get that. Made it full screen. So you can see it is detecting that, like, see, this is a person, this is a car, sometimes brick, some and the traffic light. Moreover, the accuracy is good at this time, and traffic light. But in a real-time camera webcam, if you are using, then the accuracy decreases very much. I don't know why. We need to solve that with some scaling or that. So we are using a very basic neural network in that. So this is a thing, fire trucks. It is overlapping a lot. That cannot be solved. Moreover, it is working fine, I guess. Yeah, I'm gonna quit it. Yeah, done. So what I'm gonna do, I'm just going to show you the code. I'll just give you a little view to the code. So as I told, I have object detection, then cocoa names. This is cocoa names. This are the names like person, bicycle. These are the labels for the image or the video, and SSD model we have here, EVTXT. Okay, so this is the model, and we have a weight file that is frozen in, I told you, inference. Okay, inference graph.pb. This is a weight file. We cannot understand this at all. No worries. So here we have CV2. On the basic of the algorithm we have done this. So cap.set length breadth, then class names. This is a class names. So array. Then class file equals to coco dot names with opening the files. Config path is SSD mobile net, and then weights path is frozen inference graph. Then we are doing a neural network over here, that is net equals to cv2.dn detection model, and then weights and then path we are given. Then we are giving an input size. This should be in the input size, and then this input scale, all these. If you have done deep learning, creating a neural network, if you have watched my previous video, so it matches a lot over there. And then we are getting a while loop over here, so the webcam can be turned on. Then success equals to image equals to cap.read. That is all the things. Simple, very basic thing. Then config threshold is 0.5. You can decrease it, so the threshold will be decreased if length class id is equal to 0, and bb box and zip. And then we are flattening all the stuffs we are doing over here, and finally we are like drawing a rectangle over here. We are drawing a box. This box color we are giving green. Thickness is 2. You can increase decrease the thickness. 2 is the best, or I can also keep 1, so it looks a bit better thin, because if a car is driving there is a lot of traffic, so it can detect better. Now cv2.font, or the font, what labeling it will give. Output weight key. If cv2.weight key, then everything. Let me just skip. Yeah, so this is all the code. and you can also use it in your CCTV thing. You need to create a RTSP link. We will also discuss that in the next video if you want. So again, if I run it, here we go. Yeah, now it is looking better due to the thickness. What if I decrease the like the thickness of this font? Anyways, everything is fine. It is looking fine enough. So we learned how to create algorithm on object detection and also the code. The code was very simple. Just you need to understand the algorithm, and the code is on the basic of algorithm only. All the files are available on the internet, so you can get them. If you want the file, just mail me. I will send that. So that was all for today's video, guys, and again, please do hit the like button and comment below how was the video. You can also check my social media sites like Instagram, Twitter, LinkedIn. So bye bye, we'll see you later.